Welcome to the deep dive. Today we're exploring something, well, frankly, pretty shocking that cuts right across global development efforts. It's this decades-long assumption that classifying a water source as improved automatically means the water is safe to drink. Turns out, that's dangerously false. We're taking a deep dive into some new research looking at 7 different countries, and it reveals this true inequality gap between the rich and the poor accessing genuinely clean water.
Oh, yeah.
And this gap, it's potentially up to 100% larger than what global monitoring reports suggested. So we're going deep into the flawed metrics that basically masked this crisis for so long.
That really is the mission here, to show that the fight for universal access to safe water, well, it's much further behind than the statistics have led us to believe. For decades, all the tracking thing, Millennium Development Goals, the MDGs and onwards, it focused mainly on the infrastructure. Was the source piped water? Was it a protected well? We essentially looked at the hardware, right? The simple improved versus unimproved classification.
Right, like a checklist.
Exactly. But this study, it fundamentally shifts that perspective. It asks the critical question, what happens when we actually measure the quality of the water coming out of that supposedly improved source? And the core finding, really, is that the inequality in access to truly safe water, it gets massively magnified when you compare it to just looking at access to an improved source. The current system, it's given the world a false sense of security.
Okay, let's unpack that because that's a huge claim. So the study zeroes in on this gap between, the human right to safe water and the actual grim reality of access, especially when you factor in socioeconomic status or ACS. It's definitely about more than just having a tap in your house or nearby. It's about what's actually flowing through it.
Precisely.
So how did the researchers actually figure this out? To understand this hidden crisis, they didn't just rely on that old checklist of source types, right?
No, not at all.
They focused on 2 critical inputs, it seems. First, a really refined, detailed socioeconomic status index for households. And second, and this seems key, actual field testing for specific safety threats in the water itself.
Yes, and what's fascinating here is how clearly they define the 2 major types of risk that create this disparity. And these risks, they disproportionately affect poorer households. The first is chemical contamination. This can be quite localized, things like arsenic or fluoride, depending on the geology.
Okay.
The second is microbial contamination, and this is often measured indirectly by checking for the lack of sufficient free residual chlorine.
Ah, okay, free residual chlorine. Let's pause on that. Why is that the key indicator?
Right, good question. We're talking about free residual chlorine because it's the critical marker of safety against germs, against pathogens. Think of it like an invisible shield in the water. When water leaves a treatment plant, it needs to maintain this chlorine residue throughout the distribution system. It's the safety margin, It's the residual disinfectant that kills any bacteria or viruses that might try to sneak in through leaky pipes or contamination points on the journey to your house.
So if that shield is gone.
If that shield is gone or too low, the water isn't reliably safe anymore, and this study found, systematically, the poor are missing this protection far more often.
Wow. That makes the task much clearer then. So the researchers, they compiled this household SES data with measured water quality data. And they did this across 7 really diverse countries: Bangladesh, Peru, Ethiopia, Jordan, Nicaragua, Nigeria, and Tajikistan. That's a pretty wide net.
Yeah, they really wanted to test the hypothesis across different continents, different types of water systems, different economic contexts.
Okay.
And we really need specific examples, I think, to illustrate the enormity of the problem this reveals. Let's start with a classic chemical challenge: arsenic in Bangladesh. The study found a really striking wealth gradient. Wealthier households were significantly less exposed to arsenic contamination in their drinking water compared to poorer households.
Okay, and the reason for that exposure difference, it seems almost built into that old improved classification itself, doesn't it?
Right.
I mean, if a shallow 2 well was classified as improved under the old MDG metrics, how many millions were basically given a false sense of security? They were effectively being condemned to chronic arsenic exposure, potentially, because the metric was just bad.
That is precisely the insight. You've hit it. The poorest households were often relying on those shallow tube wells. And due to the local geology in many parts of Bangladesh, those shallow wells are far more susceptible to arsenic leaching from the ground. Meanwhile, richer households, they were able to invest in much deeper tube wells, which often reach safer water aquifers, Or they had access to piped municipal water systems, which usually have some form of treatment or source protection. So the danger isn't just the type of, well, improved or not, it's the depth and the treatment, which are directly linked to socioeconomic ability.
That's a really clear chemical and geological divide tied to wealth.
Yeah.
Okay, now let's look at the other side of the coin. You mentioned the systemic failure in disinfection. This is where the failure to maintain that invisible shield, the chlorine, comes in. And you highlighted residual chlorine in Peru.
Yes.
The Bangladesh example makes a kind of geological sense,
Mhm.
shallow wells, arsenic in the ground. But Peru, this sounds more like a system breakdown, right?
Yeah.
They often have piped water, they have treatment plants. So why is residual chlorine compliance such an issue there, particularly for the poor?
It indicates a failure often to maintain treatment effectiveness across the entire distribution network, especially towards the end users, who are often the furthest out or in areas with older pipes.
Okay, so what did the numbers show?
Well, the study found that among richer households using piped water that came directly into their dwellings, chlorine compliance was measurable. It was around 10.15%.
Which isn't amazing, but it's there.
It's not perfect, no, but it reflects that the treatment is generally reaching them. It's working somewhat in their areas. Now compare that to the poorest quintile, many of whom are using community taps or maybe boreholes that are still often technically classified as improved sources.
Yeah.
Their compliance rate for adequate residual chlorine was a stark 0.09%.
0.09. That's basically zero.
Effectively zero. It means practically no protection against microbial contamination for the poorest users, even from sources labeled improved.
Wow. That's the difference between possibly safe and actively dangerous water right there.
Absolutely. And these two cases, arsenic in Bangladesh, more of a geological hazard interacting with infrastructure choice, and poor chlorination in Peru, an infrastructural management failure, they really demonstrate the same outcome.
Yeah.
The poor are systematically receiving lower quality, less safe water, regardless of whether the source is technically called improved.
Okay, so let's connect this back to the bigger picture. This is where the policy failure really gets quantified, isn't it?
Mhm.
How much does actually including water quality testing change our overall understanding of global water inequality?
Mhm.
Because like you said, if the old MDG metric suggested things were generally getting better,
Mhm.
and this new metric, incorporating quality, says the gap between rich and poor is actually widening significantly, the scale of the measurement error is just profound.
It is. And this is where synthesizing the data across all 7 countries becomes so crucial, and where the policy implication becomes, frankly, undeniable. The study used concentration indices, or CIs. These are standard metrics used in health economics and elsewhere to measure inequality. Specifically, they measure the extent to which a benefit, in this case, safe water, is concentrated among the wealthy.
Got it. So what did the CIs show?
Well, when the researchers calculated the CI just for access to improved sources, using the old way of thinking, the index ranged from about 0.05 to 0.24 across the 7 countries. Now, that already signaled an issue, a bias towards the rich, but perhaps one that seemed manageable, maybe slowly improving.
Okay, 0.05 to 0.24, but hold on, then they calculated the CI for access to genuinely safe water, right? Incorporating the quality test.
Exactly.
And that index jumped much higher, ranging from 0.08 up to a staggering 0.45. Can you put that jump into perspective for us?
Yeah, that jump, especially at the top end, from a maximum of 0.24 for improved to 0.45 for safe, that's nearly double in some contexts.
Yeah.
It means the concentration of the actual benefit, truly safe water among the rich, isn't just moderate, it's incredibly high. It basically proves that the old metrics weren't just incomplete, they were fundamentally misleading about the level of inequality. The concentration index for access to safe water was, across the board, significantly higher than the CI for just having access to an improved source infrastructure.
So potentially up to a 100% increase in the calculated inequality gap. That means practically every development report published using those old infrastructure-based metrics fundamentally underestimated the crisis.
That's a fair interpretation.
We might have been celebrating the installation of pipes and taps while the actual safety gap between rich and poor was silently widening. Especially, it seems, in places like Nigeria and Tajikistan, where the study found the quality gap was most severe.
Yes, the study confirms that core insight. Current monitoring, the way it's been done, masks substantial systemic inequalities. Even where piped access exists, the quality of that piped water often varies drastically by wealth. In countries like Nicaragua and Nigeria, the wealthy have significantly higher rates of receiving water that meets basic chemical and microbial standards compared to the poorest, even if they're technically served by the same utility or system type.
The crucial takeaway then for future monitoring for the SDGs and beyond is that the simple, binary, improved approach. It's not just insufficient, it's arguably ethically and empirically bankrupt. It's a historical failure.
I think that's fair to say, absolutely. Future international monitoring programs need to integrate both measured water quality actual testing for key contaminants like arsenic or E. coli and checking for disinfectant residuals like chlorine. And they need to link this directly to comprehensive household socioeconomic assessments to provide an accurate and ethical picture of progress towards the human right to safe water.
Because without linking safety back to wealth,
You miss the most vulnerable populations entirely. You misdirect resources. You fail to see the real problem.
so what does this all mean for global policy going forward? I mean, given that the MDGs and then the Sustainable Development Goals, the SDGs, relied so heavily on this binary classification, is this study essentially saying that maybe a decade or more of global development reporting on water was built on fundamentally flawed data?
I'd say it's arguing the data was dangerously incomplete and therefore misleading in its conclusions about inequality. The paper strongly suggests, that classifying a water source based only on its infrastructure, the pipes, the pumps, the type of, it fails completely to capture critical risks like arsenic exposure or perhaps even more globally pervasive, the lack of effective disinfection reaching the end user. This isn't just a small tweak to a spreadsheet model. It requires a wholesale shift in how we invest in water systems and how we monitor their actual performance for everyone.
Yeah, it really makes you rethink every, international development photo op showing a newly installed tap or pump handle. We might have been celebrating the hardware, the tap, when we should have been intensely focused on testing the invisible, potentially deadly water coming out of it, especially for the poorest users.
And this finding, it has massive implications for how policy is deployed on the ground. If you only track infrastructure status, you implicitly assume safety follows the infrastructure, and you therefore ignore the critical operational failings that predominantly affect the poorest households. Things like sporadic chlorination, insufficient maintenance budgets leading to leaky pipes, proximity of sources to contamination points, lack of household treatment options. The data strongly suggests we need much more sophisticated, continuous, quality-focused testing, and it must be directly linked to user socioeconomic profiles to be meaningful.
That certainly makes the task much harder, much more complex, but also far more accurate and ultimately more just. Thank you for taking this deep dive with us. We really hope this gives all of you listening an essential new perspective on what it truly means to have safe water and the tremendous work that's still left to do in bridging that often invisible but very real gap.
And maybe consider this final thought as you go about your day. The resources required for these kinds of integrated monitoring systems, regularly testing water for pathogens, for chemicals like arsenic, for disinfectant residuals like chlorine, and then consistently linking that data back to comprehensive household economic status across entire countries, those resources are vast. So given the severity of these findings, showing how much we've missed is the biggest challenge moving forward, purely scientific and logistical. Can we actually test all the water everywhere? Or is it fundamentally political and economic? Because implementing true safety, ensuring that invisible shield reaches everyone, requires a deep commitment to the poorest and most marginalized, a commitment that goes far beyond just laying the initial pipe.